Afternoon, students. So we have studied the standard forms for integration, I mean indefinite integrals. Okay, so in that chapter we have introduced integration. How will you integrate functions, trigonometric functions, inverse functions, logarithmic functions, all type of functions. Okay, and then some methods of integration are going to be studying in this chapter. Methods of integration, there are mainly two methods of integration. Most important important methods of integration are two types: by substitution and by parts. Okay, integration by substitution and by parts, these are the main two methods of integration. Okay, in the previous class you have studied about substitution. I have told you we have to substitute in logical, in questions. Yes, what should be you have to do, and in it is very elaborately defining here also. In this method, by a suitable substitution, the variable x in integral f of x dx, which is changed into another variable t, u, anything, okay, so that the integrand f of x is changed to f of t. Here t is taken, so t, which is easily integrable. Okay, so we have given a question which f of x dx. You have to integrate f of x dx. So f of x dx integration is become very tough to you. Then for making it easy, you have to use the substitution method. So you are converting that given function into another function which of an independent variable t, that is f of x to f of t, which that f of t is easily integrable. Okay, for making it easy to integrate easy, we have taking this step, or we have using this method. So for example, if you have to integrate integral x cos x square dx, so it is in one look it is very difficult to you. So for that, take d by, you know the derivative of x square here, so it is 2x, and there is x here. Okay, x is given here, so x cos x square dx. For that, substitution is taking for x square, replacing x square as t. And what is dt? Dx by dt, dt by dx, what is that? It is dx by dt is 2x dt. Okay, that is dt by dx, 2x into dt. Then x dx is 1 by 2 dt. Then x dx is there in the question. So replacing x dx by 1 by 2 dt, you get cos t 1 by 2 dt. Yes, so 1 by 2 is a constant, and cos t 1 by 2 into integral cos t dt. So in the integration become very easy. Okay, then it can be integrated. What is the integral of cos t? Sin t. So 1 by 2 sin t plus c, and then replace t. Don't forget to replace t. Then we have putting or letting the value t. So after the integration is integration is over, please not forget to replace t. Okay, that is the method of substitution. And there is no rule for suitable substitution. Practice will help you, that is given. Okay, so we have to practice many questions, then you will get the easy method, how the easy to letting which should be the t function or u function. Okay, and for some easy method that is given, if the integrand contains root of a square minus x square, put x is equal to a sin theta. Okay, that is some methods which is some rule. It is not rules, but some easy guidelines that is given to you for letting the value. Okay, please follow this also. Okay, for a square plus x square, put x is equal to a tan theta. Okay, remember these guidelines. It will help for you to put the value, letting the value, not put, letting the u or t values. Okay. And two important forms, that is integral f of x the whole raised to n. This has to be studied in the previous class. So integral f of x the whole raised to n f dash x dx is fx the whole raised to n plus 1 by n plus 1 plus c for n not equal to 1. That is, if the integrand is the product of a power of a function and its derivative f dash x is given, then product of the power of a function and its derivative, then the integral is obtained by increasing the f of x by 1 and dividing the result by the index. Okay, that is first important one. And second one is integral integral f dash of x by f of x into dx, okay, is log of f of x plus c. That is the integral of a fraction whose numerator is the different derivative of the denominator, and then the answer is log of the denominator. Okay, these are the two important forms. First is this and second is this one. Okay, and examples has been given. Okay, t function, how will you letting? First question is integral 2x minus 1 by root of x square minus x minus 1. So you can let the integral, that the denominator inside the that the denominator is a square function, and the square inside the square root, that term is t. Then 2x minus 1 dx is t. Then you can easily put 1 by root t dt. Okay, yes, so the integration become very easy. So second question is same and third question is also the same. Okay, and some exercise questions are there. All are for which is used as method for substitution method. And integral of some standard integrals. Integral of tan x dx is always log of sec x plus c. Okay, this is also an type. And integral cot x dx is always log of mod sin x plus c. So if you have given this integrals in your question, you can directly apply this because it is standard integrals. Okay, that is why you have to be study this. Okay, so and next is integral cosec x dx, which is log of mod cosec x minus cot x plus c, which, and second form is there, log of tan 1 by 2x plus c. Two forms are there. And for integral sec x dx, there is two forms. First is log of mod sec x plus tan x plus c, and log of mod tan of 1 by 4 pi plus 1 by 2x plus c. Two forms. Okay. And then next is the method of integration by parts. This is a very important method also. For this, you have two functions, which is if f of x and g of x are any two differentiable functions of x, and capital G of x is the antiderivative of small g of x, and then g of x is equal to integral g of x dx. Then integral f of x g of x dx is equal to f of x into g of x, capital G of x, minus integral f dash of x into g of x dx, where capital G of x is integral small g of x. This is integration by parts, which is very important. Okay, so what you have to do is, two functions will be given for integration. Okay, first is write the first function. Okay, f of x dx. Okay, write the first function into find the integral of the second function. Okay, find the integration of the second function and write as the product. First into integration of the second. That is the first f of x into g of x, capital G of x, minus integral of derivative of first function f dash of x into g of x, which is already written, derivative of the second function into dx. Okay, this is to be found out. Okay, that is integration of the product of two function is, it is the product formula also, integration of the products, which is first function into integral of the second function minus, okay, minus integral of the differential derivative of the first function into integral of the second function. Okay, this is the method of difference integration by parts. Okay, example is given. Integral x cos x dx. So two functions of x is given, x and cos x. So x is the first function and cos x is the second function. So what it should have to be do? Yes, first function into, write it in the definition also. First write in definition. First function x into derivative of, integral of the second, integral cos x dx. First part is over. Minus integral, put the integral sign first, then put in brackets, derivative of first, d by dx of x into integral of the second, integral cos x dx. This should be in bracket because we have finding the product of this and then we are integrating it. So it should be in brackets dx. Then first x, what is the integral of cos x? It is sin x minus, you are not putting that c here because the integration is not over. That is why the second term is also to be integrated. So integral, what is d by dx of x? It is 1 and integral of cos x dx is sin x, then dx. Then x sin x minus integral sin x is minus cos x. Then x sin x plus cos x plus c. It is the answer. Okay. Yes. Yeah. This is the how to be integration by parts. And next is also illustrated for easy for to getting problems not to be difficult. This is given to find product of two different functions of x into dx. A table is given. First function, another if it is a trigonometric function. Two functions has been there for integration by parts. If you have to apply integration by parts, there should be two functions. Okay, first function, first column is the first function, the type of first function. Second is the other function. Second function should be any type. So first is the power of x. If the first function is any power of x, second is a trigonometric function. It may be a trigonometric, an inverse, a power of e, logarithmic, and logarithmic, and then again inverse function. Any type of function is given. So what is the illustration? This is first which function should be taken as first and then which should be taken as second. Illustration, integral x dx, x cos x dx. Such type of function is there. Then first function is power, second is a trigonometric function. So take x as the first function and the trigonometry as the second function. Okay, and x square sine inverse x. Then also take inverse function as the first function. Okay, that should be remembered. Inverse as the first function and the power as the second function. Power of x as the second function. Okay. So, for if a function and a trigonometric function is given, the power of x is the first function and trigonometric function is the second function. If the inverse is given, inverse trigonometric function is given, put the inverse as first, take the inverse function as the first and then power as the second. Okay, and also if power of x is given and power of e is given, then take power of e as the second and first function as the power of x. And also for logarithmic functions, take logarithmic function as the first function and power as the second function. And if a trigonometric function and a logarithmic function is given, take the logarithmic function as first. So anyway, if logarithmic function is given, take it as the first function and the other is second function, and apply the integration by parts. Okay, yes. And if a power of a function and cos or sine, cos f of x or sine f of x is given, then doesn't matter, if you choose any can be taken as the first function. Okay, that is not bothered. And single logarithmic inverse function like integral log x dx, integral cos inverse x dx, take one as the second function. Okay, if this type of function is given, there is only a logarithmic function, inverse function is given, single type questions, take one as the second function and this as the first function. So logarithmic functions and inverse functions should be taken as the first function and the other as the second function. Okay, that should be remembered. Okay, and these are the examples of first x cos x, x sec square x by parts. Okay, I think I can't, it is I think it is got by you. Okay, and these are the exercises also. So this is all for integration. Okay, in indefinite integrals. What is indefinite integrals? It is f of x plus c. That function is a indefinite integral. And how will you integrate all the functions? Okay, and two types of method which is very important: substitution method and integration by parts. Textbook contains all questions, many questions which is problems which are solved using integration by parts and by substitution. Please work out that all problems. Okay, that will help you. Okay, and also the exercise problems, many exercise problems are there. Try to work out as problems as possible, not just one time, many time. Practice it, then it will get easy for you. Okay, so this is all for indefinite integrals. Okay, thank you students, have a nice day.